In this first video, we're going to learn a little bit more about some of the special features of our microcontroller and its expansion board. We'll start with a bit of a chicken and the egg problem, where we're going to play around with the display on the screen. Our expansion board here has a nice little OLED display that we can put whatever information we want to on. And the first information that would be really nice to put on there is the IP address, so that we don't always have to have our board connected to our computer to know what the IP address of the board is. So what we'd want to do is navigate to the code directory, which I'm already in here, and check out the display demo. The display demo just imports the display library that I wrote and adds this simple little text to the screen and draws it. To run the demo, we would need to run jag run. Well, first I would actually want to plug the board in. And we can see the green lights on the encoders have come on, and also the red LED on the board itself. And then the green LED up here is flashing because it's saying we're not actually charging any sort of battery. To run this, I'd want to say jag run demo.toit, and I'd have to pass in the device. And I'd need to know the IP address of the device. Currently, the only way for us to know the IP address is to run the jag monitor command. And after a bit of time and a little bit of luck, my device was able to connect, and it spits out its IP address. So now I can type that in to my command up here. First thing you might notice is that this won't actually run when you just change directory into the display directory. We get a lot of error messages out here. Most of them are just talking about how a package cannot be found, which is absolutely true. And that's because the display code, so if I show you the top of that file, imports a bunch of non-standard libraries. Jag calls them packages. So what we really need to do first is install the dependencies with the jag package install command. Once that's done, we should be able to run our run command. And we see a couple of bits of output here. The first is that we actually have something showing up on the OLED screen. And down below we can see that our script started and then stopped. And one nice thing about this type of screen is even if our program is done running, it'll still maintain whatever was last displayed on it. Let's start setting up our own program that uses this display code and will eventually display the IP address of the device. I'll just open up the entire directory. Change my window size a bit. Hop back over here, and I'll create a new directory for this. Let's call this the display IP demo. So this is the file we have, and we're going to start by just stealing some of the code from the display demo itself. The error message here is nice, in that I'm no longer importing this from the exact same directory. So if we go back to our previous directory, which was display, I'm showing you the code that's found inside the demo file. And the demo file imports display as .display because the display file is in the current directory. You could think of this dot as just saying, look in the current directory. That's what Linux will a lot of times, or Unix systems will a lot of time call the current directory. So if I cd into dot, that's like basically saying cd into the current directory. Dot dot is one directory up. And so that's what we need to do here is just say, okay, well the display directory from our new demo is one directory up, and then you can find it inside the display directory. Let's call this the IP address for now, because we don't actually have access to it. And see if we can actually get this running. And one nice thing about knowing your IP address and not have is that you don't actually have to type it in every time if you're a bit clever with how you use your shell. So I'll show you on my shell, which is called fish, a clever way to remember it. I'll call it the JAG IP. And when I set this variable equal to my IP address, I can now refer to my IP address with just JAG IP instead of having to type out the IP address every single time. That's pretty convenient because then my command can always be jag run the name of the file, and then for device I can give jag IP, and now every time I run this it'll always be jag IP, but if my IP address gets changed by the network, I can just rechange or re-export this variable. And you can see when I'm not running the package, or importing the package in the same directory in which the package is found, these import errors start to come back again. I haven't found an easier way for this other than just creating a package and uploading it to the package repository so that it handles dependencies better. But one quick solution to this is just to copy the package file into our current directory and then run the package install command again. And now we have our demo over here with our new output. So that's the basic idea behind the display demo. We'll want to get the IP address. We'll need a separate library for that, the communication library that I have inside a different directory, found inside the communication directory. And we'll need to combine the two of those. But before we do so, it'll be worth digging into the actual display library itself in a little bit more depth. So at the top you'll find a bunch of import statements, and these were more or less just copied from their tutorials. A lot of these are standard libraries from the standard library. Some of them are not, and they had to be installed, but they all start pretty much the same way. Import, the name of the library, and then I'm in a habit of sort of taking some of what I've learned over from how I like to write Python code, which is to always just import the names from those libraries that you're actually going to use. There are different ways to do this in TOIT. You can look through the documentation, but if I'm going to need pin from GPIO, I'll just import pin from GPIO essentially, and then I can use pin directly, like I've done down here. For anything that you see that's relative with the dots here, that typically means you'll find that library relative to the current directory. So if I jump back over to my terminal and I go into the display directory again, you'll see that I'm in this directory importing something one level up and then a directory called pinout. So I should be able to say what's in pinout, and inside there you'll find a single file called pinout, and that's a file we'll visit later on. A few other things worth mentioning from this fairly small library is a couple of style things that are part of the TOIT style guide. If you have constants, typically you'll put those in all uppercase and use : equals to set them. So now instead of having to call font.get sans10 everywhere, I can just use the constant sans. Likewise, my style that I have here for default for the display we have is for a color of white, and to use that sans font. TOIT is an object-oriented programming language, so kind of similar to how you might write Python, but probably even more closely related to how you might write some Java code, just with more Python-like syntax. So here I have a class called display. I have a couple of static variables. So these are the same and only show up in memory in one place. They're the same if I had multiple display objects being created. For example, here I'm creating a display. This is the class type, and then this is the variable that I have that's an instance of the display type. So I could do something like display dot and then grab out the SDA pin, for example. But since it's a static variable, it's actually better to do so on the class itself. Well, a few nice features from a more modern language like Toit is for larger numbers, you can put an underscore just to visually break up that this is 400,000 instead of just 400. 4 with a bunch of zeros. It's easier to see that this is 400,000. And this syntax might catch a few of you up because it's a little bit different syntax than you're probably used to. This is the name of a member variable, and the type is given after the slash. So my display member variable is of type pixel display. And that's not initialized anywhere because it's a instance variable, meaning it only gets created inside the constructor. And one nice feature of Toit is that if I forget to do so, let's say I comment both of those out, it'll say, hey, you have a field called display. Field is another name for a member variable, and you never initialized it. So Toit has a lot of really nice features like this. I think you'll find it to be pretty similar in style, syntax style to Python, but coding-wise, like I said, a little bit more closely related to something like Smalltalk or Java. Scanning through the rest of this document, the only other things really worth picking out are the instance methods. So I have an add text method, and it's pretty standard style to use a hyphen to separate the words and the name of a method or variable in Toit. I can have optional arguments, and they can have default values. And this particular class has two instance methods, one called add text and another called draw. And you can see how I use them here. Much like maybe a language, like a functional programming language like Haskell, you don't actually have to use parentheses to pass in your arguments. And if you don't have any arguments to the function like the draw method, nothing has to come after it at all.